In our session today, it is a continuation of what you're doing earlier on. Recall in our last. Hello, learners. Welcome to our session today. I am your instructor, CPA Ringo Frederick. In our session today, it is a continuation of what you're doing earlier on. Recall in our last class, we had introduced the aspect to do with, talk about the aspect of operation of matrices. In our session today, I want us to talk about application of matrices. And you will find that matrices is always, or many a times, is used in our day-to-day business activities. So it will be very important for us to understand each and every concept behind the application of matrices. So looking at application of matrices, number one application that you must always be very good at, this is number one, talk about the aspect to do with solving simultaneous equation. That is, of course, solving simultaneous equations. Solving simultaneous equations, solving simultaneous equations. That's number one application. Talk about the aspect to do with the input-output matrix. Talk about the aspect to do with the input-output analysis. Of course, input-output analysis is a concept of economic factors, whereby you normally tend to say whatever that you produce, of course, is the one that you're going to kind of generate, and also it depends with how the market will behave. Talk about number three, we normally tend to talk about this is Markov process. Markov process. So these are the main application of matrices that we'll be talking about. And in our class today, I want us to start with the first one, and that is solving simultaneous equations. Using matrices in solving simultaneous equation. That is what I want us to start with. So solving simultaneous equation. Solving simultaneous equations. So this is one application, the first application that allowed us to concentrate on. I know by now we are very familiar. Whenever we're talking of simultaneous equation, basically, it's not a new term. It's not a new term at all. So in solving simultaneous equation using matrices, you normally tend to use two ways. That is, of course, you normally consider the inverse method, and also you normally tend to talk about what is known as what? Crammers rule. So in solving this, you say that we'll be talking of two. That is number one, talk about Cramer's rule. Cramer's rule in solving simultaneous equation. Or rather just Cramer's rule. And number two, inverse method. So these are the two ways that we are going to use, or methods that we are going to use in solving simultaneous equation. So in that case, I want us to jump straight to Cramer's rule. And see what that will entail. So let's jump straight to Cramer's rule. So anytime you're looking at Cramer's rule, my good students, some certain concepts must always tend to click at the back of our mind. This is, of course, you'll always be looking at a case whereby I'm given a form of matrix here. Given this form of matrix, in that case, you normally tend to use a concept known as what? Replacement method. In that, we will be talking of various component, which we normally term it as a replacement column. We normally term it as what? Replacement column. We normally term it as replacement column. Take, for example, for me, or rather for us to understand this concept clearly, take, for example, this illustration. Let us start by 2 by 2 matrix. By now, I know we are very familiar. Anytime you're looking of our matrices, we are very familiar with that order of the matrix. Looking at 2 by 2. Take, for example, this case, I'm having this illustration of ours. I'm having, say, like I'm having, we can have, say, 2x plus 2x minus, say, like 5y, which will be equal to 7. Then we also do have, say, like, I'm having x plus 6y. This will give us 9. This is one equation that I want us to look at. This is one equation that I want us to consider and look at. I want us to use simultaneous. I want us to use Cramer's rule. So in Cramer's rule, what I want us to focus on and understand, this is what you are terming it as what? As a replacement. This is what you are terming it as replacement column. That's first thing that you need to understand. That is what you're terming it as replacement column. So step number one in solving this case, my good students, step number one, we need to determine what is known as what? As base matrix. We need to determine what is known as a base matrix. And how do you determine our base matrix? So clearly, if we want to determine our base matrix, in this case, as if we are talking about here, I'm talking of 2, that is a minus 5, right? XY, I'm having 1, this is 6, which in this case, you're going to multiply by x and y to give us what? 7 and 9. That is what we should be having. From this equation, we can derive a matrix form in this case. From that equation, we can derive a matrix form in this case, whereby in this case, we find that I'm having 2, that is, of course, 2x minus 5y. So you're taking 2 minus 5, then you're having x, the first bit. Then we talk of y. In that case, we're talking of x plus 6y. So I'm having 1 and 6, which in this case, xy is equal to 7, 7, or 7, 9. These are matrix, right? So what you're going to say that, you see this is what you're going to term it as what? As our base matrix. This is what you're going to term it as our base matrix. That is what you're going to term it as our base matrix. So step number one, you've said, is to determine our base matrix. And our base matrix, that is our base matrix. Step number two at this point, my good students, let us determine the determinant of our base matrix. Let us determine the determinant of our base matrix. Recall determination of this as step number two. We're saying you want to determine determinant of the base matrix, determinant of the base matrix, determinant of the base matrix. And how you determine the determinant of the base matrix, my good students? This will be very simple. Recall, for us to determine determinant, we normally tend to talk about product of primary diagonal minus product of secondary diagonal. That is what will give us our determinant. Product of primary diagonal minus product of the secondary diagonal. That is what will give us what? Our determinant. Or in that case, therefore, we should be having this case now. I should be talking of product. Take our base matrix. Our base matrix, we've said, you should be having 0, or rather 2 minus 5, 1 and 6. 2 minus 5, 1 and 6. These are base matrix. So how will we determine our determinant? Product of primary diagonal. Of course, we mentioned, and now I know we are very, very good in identifying our primary diagonal, right? We say that our primary diagonal will be a figure, or rather, we're going to start from our first element of our matrix going parallel. We are kind of cutting across like that. So this is what you're terming it as what? As a primary diagonal, starting from the top left to the bottom right. Any figure that will lie in between, that will give us our primary diagonal. And of course, so this is our primary diagonal, this is our primary diagonal. And of course, this should give us what? Our secondary diagonal. So therefore, at this point, you can confidently come and determine our determinant. So therefore, determinant would be 2 by 6 with less what? 1 minus negative 5. So that should give us a determinant to be equal to what? That should give us a determinant to be equal to, we should be talking over, of course, here we should be talking over, I'm having 2 by 6 minus 1 by negative 5. That should give us a figure of 17. That should give us 17, right? So that will be our determinant, which again, we must have very well, or we must always tend to recall that procedure. After we determine the product of our primary diagonal, my good students, if you are to talk of a step number, if you talk of a step number 3, this is the most important step. We should come and determine the determinant of the numerator matrix. Determine the determinant, or rather determinant. We are talking of a determinant. We need to determine the determinant of the numerator matrix. And the question will be, how will we determine the numerator matrix? At this point, this is where the concept of replacement column will kick in. This is where the concept of replacement column will kick in. Take, for example, this case. I'm having our matrix. Remember this case, what we had here? We had 2, negative 5, 1, 6. Ignore x and y. In this case, we should be having 7, 9, right? So our replacement column, this is what you are having it as our replacement column. This is what we termed it as a replacement column. That is what we termed it as a replacement column. Okay? So we are going to replace, in this case, because we baptize that with a replacement column. Now we can agree that 2 and 1, these are our values of x and these are our value of y. If I want to determine the value of x, what you are going to do is to replace the values of x with what? Our replacement column. In this case, my good students, Mwalimu is saying that if we want to determine the value of x, what you are going to do is to replace this column, is to replace the matrix, or rather the column of x with what? With the replacement column. So in our matrix here, we can agree, in this case, we should be talking of 7, 9. In that case, we've replaced that, which in this case, I'm having 7, 9 and negative 5, 6. So that is what we should be having. So this is what you're going to term it as what? As determinant of the numerator matrix. Or rather, that is, these are numerator matrix. Of course, you can proceed and determine the determinant on that. So the determinant of this numerator matrix, which at the end of the day, of course, you know very well that Crammers rule will have determinant of the numerator matrix, we divide by the determinant of the base matrix, which will reach there. So let us determine this determinant of the numerator matrix. To determine the determinant of the numerator matrix, of course, you can do for x and y. So you can do for x and y, so that at the end of the day, make sure that here we are saying, we're talking of, we're going to divide this by the determinant of the base. What about, my good students, if you are to determine the numerator matrix for y? If you're to determine the numerator matrix for y, what you are going to do, we are going to replace our values of y with what? Our replacement matrix, or rather replacement column. So if I was to replace y, in this case, we should be talking of 2, 1. Remember our base matrix, or our original matrix. I'm going now to replace, this is x, this is y. We're going to replace our y with what? Our replacement column, which in this case, we should be talking of 7 and 9. So that at the end of the day, we should just determine that one. We are going to divide that one by the determinant of the base matrix. So solving this, let us determine the determinant of the numerator matrix. product of primary diagonal minus product of secondary diagonal. So primary diagonal is 7 by 6 in this case, right? In this case, you are going to deduct by 9 times -5. That should give us what? That should give us determinant of that numerator matrix. That should give us a figure of how much? 7 by 6 minus 9 times -5. So that should give us 87. That should give us 87. At this point, remember, we had already determined the determinant of the base. We had already determined the determinant of the base. Actually, I've jumped several steps ahead, right? So determinant of the base, in this case, we had 17. Remember, the determinant of the base matrix, determinant of the base matrix, determinant of the base matrix, we had 17. So therefore, we are going to divide this one by 17. So that will give us our value of x. What about value of y? For value of y, the same case, product of primary diagonal 2 by 9, with less product of secondary diagonal 1 by 7. So that at the end of the day, that should give us what? That should give us, of course, 2 by 9 minus 1 by 7. That should give us 11. So we're going to have 11 there. And of course, determinant of the base matrix will not change. I should be having 17. So having up to that point, you can now clearly come and determine the values of x and y. And how will we determine the values of x and y? That will be simple because I'll just be taking now 87 to divide by 17. That should give us x to be 5. And y, that should give us 11 divided by 17. That should give us x to be, getting y to be 0.6. 0.65. So that's the figure that you're getting, and kindly you can confirm with Mwalimu. Kindly you can confirm if we are getting the same answers. Kindly you can confirm if we are on the right track, all of us. Kindly you can confirm if you are on the right track. So confidently, we can come and say that therefore, in this case, we've solved our matrix by determining the value of x to be 5, whereas value of y to be 0.65. 0.65. In that case, you are looking at what? In that case, you are looking at 2 by 2 matrix. So in our next session, my good students, we are going to use Cramer's rule, but in this case, we will be looking at what? 3 by 3 matrix. See how it will happen. How it will happen. In our next case, we're going to look at Cramer's rule, but in that case, we're going to use what? 3 by 3 matrix illustration. To that point, thank you so much, and let us meet in the next session. Thank you.